Hello. So we're going to expand the moment inertial a little bit and analyze the moment inertial. So I moment inertial, right, which is kg meter squared. And the determining factors, right? And what are the factors that impact the I? So there's three things that we can think about. One is distribution of mass. Of particle, right? Distribution of mass in this 3D object, right? And two is the geometry. So what kind of shape is your object, right? So this I is for an object, right? For a 3D object. Keep that in mind, right? Rotation, we're thinking about a 3D object now rather than a point mass, right? So geometry, right? So is it a disk, right? 3D, right? So is it a sphere, right? Is it a irregular shape, right? Which will be really tough, right? And so on, right? Okay, and number three, which axis? Where is the axis of rotation, right? So if you change the axis, your I will be different, right? So those three things, it's all impacting your axis of rotation. So think about the number one first. So if I have, let me erase it, okay? Keep it nice and neat. All right, so number one, we say the distribution. So in Chinese, this is a 分布, right? 质量分布, okay? All right, so if you have two objects, okay? So you have two objects. Consider two objects, two 3D objects, okay? One is a disk, okay? Solid disk, a solid disk. Okay? Two objects with same M and R, okay? And the other one is a ring. So it's a hollow, right? It's a hollow ring. So it's just gonna make it like, right? Just all the mass is right there. So inside here, this is a hollow. So in Chinese, this is 空心, right? 中空的. Okay? 你的心被掏空了. Okay? All right? So, but the R is the same. So let's just draw the R right now. The R is the same. The mass is the same. This M, right? And this one here, all the mass is in the outside, right? This is also M. Let's say, well, so this is also R. So in these two cases, I are different, even though they have the same I, same M, same R, right? So same M and same R, right? The same, okay? But so let's say this is 1 and this is 2. So your I1 is obviously not the same as I2. Right? Because of what? Because your distribution of mass. So this one distribute the mass everywhere, right? Here, 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 here. But this one only has the mass right there. Only the mass at the outside. So which one do you think is going to have a larger I, right? Okay. Of course, right? This is the one, right? Because you have every single particle have the same R. Okay, so this one here, let me change in color here. Okay. R, right, for all particles, right? Same R. But not this one here. If I'm looking closer to right there, for example, that one there, this is M little 1, right? There's a little M1 there. This one here, the R1 is equal to 0, right? Because it's just right at the center. So that one will not contribute to I at all. And then you look a little close. Let's say you look at this one now, right? And make that R very small, R2. And this is the M2. And R2 is 10 to the negative 10, okay, meter. Then this one also contributed nothing there, okay? Even though it contributes to the mass, but it does not contribute to the I, okay? So it's a turn out this one here, this I1 is equal to 1/2 mR squared. And this one here is just equal to mR squared, right? There's no 1/2. So you can see I2 is equal to 2I1. And this one here, by definition, this is equal to summation MI RI squared. But all the RI is the same because every single particle has the same R. So when the R comes out, the R squared comes out, right? And then you summation MI. So summation MI, it just gives you the M. Okay, so then it becomes MR squared. All right, so that's distribution. And let's think about the geometry, okay? So the geometry. So if we have geometry like this, like a circle, okay? Versus you have a geometry like, for example, like something like, let's see, what I want to draw. I want to draw something also 3D, okay? But it has this shape, for example. Just the mass is here, right? And you have this stick has almost no mass. And then you have another one here. And so this one is M. Let's say this one is M. And this one is M, for example. So you have 2M, right? And this one here is 2M, for example. And this one here is R, right? And let's say this one here is also R. So this two geometry. So this is like, I have one mass here. And now I have another mass there, okay? And let's just say that this one here is high density. So this M, I'm changing color here. This R, okay, this R here is much, much smaller than R, okay? So then you can consider M here to be as a point mass. Okay, so basically means this entire M has the same R, right? Everybody has the same R, and same here. This side here is also R, okay? So every single point here had the same R because they are so small. This little r is so small. Okay, so now we have two geometry, right? So this is geometry factor, right? Okay, so now this is kind of like a dumbbell, right? You can call that a dumbbell. Dumbbell, P-E-L-L, right? Dumbbell, right? Yaling. And this one here is the disc, right? So there are different geometry. You can see they will have different I, right? So this I1 and I2 will not be the same. This is 1, 2, even they have the same M plus M is 2M, you have the same R, right? So this one here will be I1 is equal to 1/2 2M, right? 2M is the M, and then R squared. So that's equal to mR squared. How about this one here? This one here, you have this one here, M times R squared, right? So that's equal to M times R squared. And then you have this one here, M times R squared, right? So M R squared. You can see this is 2 times mR squared, right? So this I will be bigger, right? So this I2 is 2 times of I1, right? 2 times of I1. So this is harder to rotate, okay? This one here harder to accelerate angularly, right? Angularly. Okay, all right. So obviously the axis will matter too, okay? Let me just draw it here, but we're not gonna go into it in this lecture. So let's say if I shift this one here to here, how about here? If I put it here, okay? Instead of the axis here, this is the axis, the O one, right? This is the O axle. The new axle are shifted here. You can see this one here would have no contribution, right? Because it's 0 R, right? So then all you have is this one here now. then this I will be I2 prime, right? This is a new exo called exo prime, right? Is equal to M, still the M, right? And the R now is 2R, so you have 2R and square. So now you have 4mr squared. So this one here, the I2 prime, will be 2 times of I2, right? So it's much harder to rotate when you have this, okay? All right, so we're gonna stop here. When you can see the factor of this tree, right? This tree here, we have distribution, and they all kind of like, you know, kind of overlapping a little bit, you know, and this is the axle, right? Okay, these three are the factors that impacting your I computation. I'm going to stop there. Okay, have a good one, and we'll see you next time. Bye-bye.